G'day guys, Matt from HAL Heavy Duty. We are the machine shop for a 60-year-old drilling company up in Queensland, and our job is to just keep rigs running. We fix all of the gear that drillers break, and we make all the crazy custom stuff these guys need to get the holes dug. And these holes range from 75 mil right out to 3 meters. So you're talking 3 inches to 10 feet. Our mega drill project, which is the largest hole we've ever attempted, is about to kick off. For the last 4 months, we've been building all the bits and pieces to go with it, and they're now heading out to site to test everything. And if you subscribe to the channel in a future video, you're going to actually get to go to site with me, and we're going to see a hole that's big enough you could drop a car into it, go 250 meters deep or 800 feet. So if you want to see that, make sure you hit the little button. And if you enjoy these videos, please hit the like button because it really helps us grow. Anyway, let's get cracking. Lead the way, Murray. Lead the way, buddy. All right, so in today's video, we are actually making something called a non-return valve, which is a drilling sub. And right here, this is exactly what a drill sub looks like. And these get screwed in between drill rods. And the purpose of a non-return valve is so that water or the cutting fluid can only come back up one direction. This is what non-return valves actually look like. There's multiple sizes and different styles. The 3 on the left there are what we call flapper valves, and the one on the right is called a dart valve because, as you'll see, it looks like a little dart, and all that means is that the fluid cannot come back up the hole, it can only go one direction, which is getting pumped down. And these get used in a lot of different applications when you're drilling, but the problem we have with non-return valves is you have to drill very, very deep in order for them to be machined. So to do that, we're going to be using a 63mm HTS drill, and these things are wild. So I think you're going to really enjoy this video. Fortunately today we've actually got 3 billets of steel. We're going to be making 3 non-return valves. Very, very, very shady mud map here, but there's going to be a box in one end. The non-return valve is going to be drilled out to go all the way in 285 mil or 11 inches. And we can't do that really easily with a normal U-drill because it has to be at a very, very specific dimension. So this has to be drilled out at just under 62 millimeters. Today we're going to be working on our Colchester Alpha 1760. It's the largest of our CNCs. In all reality, it's probably what you'd call a medium duty CNC. I know we're HAL heavy duty, but there are bigger lathes and way more powerful ones than this one out there. But for what we do, it is a really, really good lathe. It's got just under 20 kilowatts of spindle power, enough Z-axis load that I can dig a 110 mil hole into 4140 steel. You always want more power, right? But we've got enough to get the job done. These things are great. The Colchester lathes, one of the things I really like about them is they have a mode in them called Alpha mode, which you can pretty much run this thing as a manual lathe as well. We do a lot of our repairs in here. Weighs about 7 or 8 tons. It's got 2 chucks on it, so front and back, so that I can put rods in and spin them as well. And I think those chucks weigh about 190 kilos or over 400 pounds each. So it's a fairly solid lathe. And today we are going to have a whole bunch of fun running this HTS drill. I'm going to do a little unboxing on this, but if you just want to get straight into the action, go to about halfway and you'll see us blast out those 3 billets. But for those of you that haven't seen these before or you're curious about buying one like I was not that long ago before we purchased them, this is actually what turns up. So you've got an inner cartridge and an outer cartridge, which is great because if you end up busting them up, you can just replace the cartridge and you don't have to replace the entire drill head. And we've got a whole bunch of these now because I've just found them so effective and fast, because we were using twist drills up until recently. But these HTS heads, you can make the shanks as long as you like. I've actually purchased the shank for this one, but we typically, for the bigger ones, we build our own shanks and just buy the heads at all different interchangeable sizes. So we've got this one's a 63 mil one. We've got 130 mil, a smaller one that I think is 47. I don't know what that is in inches, sorry guys. But I've stuck with the Kennametal ones because we bought the first Kennametal one, really liked it, and then we went from there. And the other thing too is I think when you're buying tooling or even machines, big part of our purchasing process is how good is the support we actually get. And the support that I get from the guys we buy this off is fantastic. So Mick and Andrew, I know you guys sometimes watch our videos. I appreciate it. You guys are half the reason why I keep getting them, because the prices are all pretty comparable, but you guys have helped me work out feeds and speeds, and these guys have a lot of experience, which I had never run these before until recently. So yeah, big shout out. One of the first things I got taught when I was learning to be a machinist was always use anti-seize, because these little screws will get stuck very, very quickly, especially when there's coolant on them and they've got a bit of pressure. Whereas if you use I found the copper stuff to be the best, and it just means that you don't have these tiny little screws that you end up snapping off or reefing out. And since we switched to the copper rather than just your basic anti-seize, I've found a real, like we haven't gotten any screws stuck really since. Next thing we've got to set up is the high-speed steel pilot drill. Now, a lot of you have asked in previous videos, why is it a high-speed steel center? And I asked the same thing of the tooling guys, but it makes sense when you think about it. So high-speed steel is very forgiving, and it's only a 10 mil center. So you can spin a 10 mil drill into 4140 steel at between 600 to 750 RPM, no problems at all. Before we stick this into the tool holder, we've just got to set the pilot drill length. So it comes with a chart that tells you how long that needs to be. So it's a 10 mil or 0.394 inch pilot drill, and we're going at least 6 times diameter, so it's 4.6 mil or 0.181 inch, and that is measuring the very tip of the pilot drill to the tip of the trigon insert. But what I need to do is create a bung to go in the back, or a sleeve, and I'm going to put a little O-ring into it. So I'm just going to check out here as to, when I just go off the charts. So we're going to make a little O-ring groove for this sleeve that slides in, that way it doesn't leak coolant out the back. We'll do a 3.53 or a 1/8 inch O-ring, and we'll just set that up, so easy as. We run quick change tool posts on all of our lathes. It's just the fastest way for us to do what we do, because we don't do large volumes of things. So having a turreted lathe is not necessarily the best for our style of work. If we were a big production facility, it would be, but we do an equal amount of repairs and do like 10 different jobs in a day. So we have very little tool setup time. But a big part of that means that every single one of our tool holders has to be plumbed in like this. So we've gotten pretty good at it for now. Little bung is going to need a 3/8 BSPT female thread put into it so that we can screw in a fitting, and I'll show you how all that works in a second. We're going to head over to the little manual lathe and we'll just knock this out quickly. We'll pop the tool in, dial it in, and then we're off to rock and roll. Just going to check the fitting screws in, and then we are going to just install this sleeve into the tool holder and get the tool dialed in. So this drill is going to be set up as a permanent tool. So it'll live in this tool holder, it'll be set up to its correct tool height and dialed in, so that once it's set up we only have to really do it once, and then that'll be tool 35. All of our drills are labelled in the 3s, so tools 1 to 10 are external turning, 20 to 29 are internal, 30 to 35 are drills. And that will then be a permanent tool labelled and set up, so that anytime I want to run it, I just have to throw it in. I'm going to be using a dial indicator to set this to where it's running to 0. A few of you have pointed out in my previous Udrill video that the dial indicator can droop slightly when we do it like this. It might by about 0.1, but I'll have to live with it. We get it dialed into pretty darn close. I would like to in the future get a coax dial indicator, but I don't have one yet, so we'll just make do with what we've got. On all the drills that we've run so far, we get them to where they run pretty darn well. Because we're running with a quick change tool post, we're not as rigid as I would like to be, so they do squeal just a little bit, but there's not much I can do about that. In future, if I get a bigger lathe, I'm going to make sure that it's as rigid as possible so that I can really hammer these drills as hard as possible. Now, if we go to the cutting data, they give you a whole variety of options, 9 different total speeds of optimal, minimal, maximal. What I'm going to do here is start it at the lowest for what they call unstable cutting conditions, right up to the top. So we'll go at 50 meters per minute, 100, and then we'll try it at 150. So translating to RPM, I'm going to run it at 400, I'm going to run it at 500, and you'll hear me probably play with it. You'll hear the RPM go up and down, and then once I've run those two, we'll just see what the max is, depending on if I've got the power to do it, because I am going to be limited by how hard I can run this, simply based on how much power and Z-axis push I've got in the lathe. The very last thing that I've got to do here is this starts out at a 63 mil. It's 60 to 63, and I actually need the size to be just under 62. So the way these HTS drills work is the inner insert you can actually mill off down to the size that you want. So we are going to go and do that. I've just checked the hole size to see what it's cutting at. I'll go off and mill just the inside of that little cartridge there. We'll give it a little stoning up to make sure that it's nice and smooth. Then we'll pop it back in and we are going to just send it. You can hear me here playing with the speed and feed. You'll see this in the second and third run why that's so important, because I just want to find out how hard I can actually run this, because I'm going to be running ideally at about 90% of spindle load and 90% of Z-axis push. So the only way to find that out is to play with your lathe. After that first run, the hole came out looking really nice. It chipped pretty darn well, and the inserts held up and the center pilot drill is completely fine. So the first one is done. We're going to pop that out, throw the second one in, and we're going to increase the speed a little bit and the feed. I've had a lot of people comment on our previous HTS video. The squealing is fairly normal from what I understand. We can't seem to get rid of it. I think it's just because of the tool post, or maybe that's how the tool is. It doesn't seem to affect the finish too negatively. It usually comes up pretty good. So as I'm playing with the RPM and the feed here, I've set it at 0.16. The previous hole we dug at 0.15. So drilled, sorry, the driller coming out at me. We drilled it at 0.15. So I just want to increase that as much as possible, because the harder I can feed it, the less likely it is to squeal. Now, it seems to me that about somewhere around 500 to 550 is going to be ideal. It'll keep me around 90% of that spindle load and under 90% of Z-axis load, which is really what I want. I think I've pretty well found it's going to be somewhere between 500 and 550 RPM. The finish on that came out really nice. Pretty happy with that, and it cut to size. Alrighty, well, let's just go beyond what I think the maximum is. So we're going to crank this up to 750 RPM. That's the absolute max. We're going to put it into high gear. I reckon it's going to go above 100% spindle load, but I can then drop it down and I'll be able to find its true maximum. So let's have some fun with this sucker. As predicted, at 750 RPM, we are way above spindle load. So I'm going to drop that down. We get 600, 590. So even at around 600 RPM, that's not bad, but it'll depend on what the finish looks like too. So somewhere between 550 and 600 is going to be ideal. 0.18 is a really good feed for running this. So I'm real happy with that. Let's see how it finishes out, and let's see what it looks like once the part is drilled. As you can see, the finish on this is not as good as the previous. It looks like some of the outback roads in Australia. It's pretty corrugated. So ideally I'm going to stick around the 550 and 0.17 for this particular lathe. I think is ideal, but that will be fine. That finish for the first sort of 100 mil isn't going to matter, because that's going to get turned into a box in just a minute anyway, which we'll do. But before we go and finish these two parts off, let's duck over to the rest of the shop and see what's going on. Got Ronnie over on the smaller of the two CNCs. We call this one Jean. We named it after my grandma. The big one, Hal, we named after Granddad. And so he is knocking out a whole bunch of different casing and also down the hole crossover subs you can see there. And that little lathe just runs all day long. We've also got a bunch of bit repair happening. So for all of our drill heads, this is only for in-house work. We don't sell any of these, but we will usually repair these drill heads dozens of times by knocking out broken PCD bits and then rebrazing them back in. So we've been doing this now for nearly 50 odd years, or as long as these heads have existed. I can remember as a little kid my granddad doing this. So it's I find this to be one of the most relaxing jobs in the shop. It's like metal dentistry. The process for doing this means that you have to heat the drill head up to 600 degrees first so that the silver solder will stick correctly to the metal and to the PCD button there. If you don't heat it up hot enough, they'll just pop out down the hole, and then you'll have a really angry driller who's got a toothless bit. So we then use these blue silver solder rods. It's very free flowing and it sticks nicely. And then if we have to build up behind the button, let's say that a little bit of the material on the actual bit itself has been taken out whilst it was drilling, we use a nickel coat style rod. So we just braze these in here and they'll be ready to chew away for another day. Usually do these in a big batch, and once they've been done, we'll send them over for their little Dulux upgrade. It's funny, if you don't paint it, the drillers don't want it, but if you give it a nice coat of paint and provided the buttons look like they've been put in properly, it comes up brand new. It's amazing what a coat of paint will do. And if we head over to the Hulk, our big green mega bore lathe, Heath is busy coring out billets for another set of drill rods we're going to be building for our second largest drill rig. These are going to be the testers for it. We're upgrading the thread, so we're going to use our big trepanning bit and core these suckers out, and we'll also get to save the slug, which is awesome. So that will be happening in the next couple of videos. For those that want to know, the Forbidden Pink Lemonade, our coolant, is called Hole Maker by ITM. Great stuff. The guys in the boiler shop have been flat out all week. Lots of different jobs, including upgrading this bucket so that it can be used by the front end loader out on site for the big rig. And they've done a bloody good job of it too. More gear is headed out to site for the big rig. We're estimating it's going to be somewhere between 16 and 20 semi-trailer loads worth of gear for the full complement of everything needed to send that mega drill 250 metres deep. One of the best parts about it being a little family business is that you have little family members running around from time to time. So there's an ongoing game, which is, let's see if we can kick Uncle Matt's toolbox. These kids have been at it for a while now, but I have developed some defence mechanisms. I'm locked and loaded. Out. Get him, get him. Ha ha. Get Grandad, get your Uncle Matt. And you know, if you can't have fun while you're working, that's a third of your life where you're miserable. So we have as much fun as humanly possible here. You know, it's a little privately owned business. We are like the least woke, most politically incorrect, in my opinion, fun place to work. And I grew up in this shed. I've been in here since I was 2 years old. You gotta have fun while you're at work, or what the hell are you doing? All right, let's get in and finish off these boxes and pins for these non-return valves, and then I'll show you how they look at the end. Little tip, if you ever get a thread that gets locked onto something, just give it a little tiny tap with a hammer and it'll just come loose, no troubles at all. You don't have to give it a big hit or anything, just a tap. So I'm just checking to see that there's no play in the thread and that it shoulders up, which this does, and that's pretty well bang on. And now to finish it off, we've got to put what's called a set of breakout flats in it, which we use Godzilla, where Teddy is, with the big mill. He loves this thing. So we just use a 50mm cutter and just plow it right through. And we use a low pitch cutter. It has 3 teeth. We find that in our style of mill, when we're using like a conventional manual mill, 3 teeth just works better than 4 or 5 or 6. We've tried them all. This will just plow through it, no dramas at all. If I get painted, the threads will get coated with defense yellow, which I will mention in a future video, all the details on that. It gets held in with a circlip groove, which we actually cut manually in the lathe, but I didn't actually get to check that. And these will go down the hole up to about 600 meters, and they will stop the fluid from going the wrong direction. So you can see it there, right to left, start, machined, and finished. Well, I am really happy with how that turned out. It's nice that, after playing with feeds and speeds, you figure out, right, that's bang on the money. It's based on your machine. If I had a bigger, more powerful machine, I could probably run it harder. But anyway, hey guys, I wanted to shout out and say a huge thank you to every single one of you that watches these videos, especially everyone that comments. Guys, we're about to hit 20,000 subscribers. And for a little machine shop in the middle of nowhere, it's just insanely humbling. I'm really grateful for all the comments, especially when you give me tips on, how I can make the videos better, or, how I'm screwing them up, which, considering when we started, it was like like watching Cloverfield. I think they've gotten better. If there's things that you think I can do, I am open to feedback. Like, there is no ego here. The whole purpose of having this channel was just because I thought we were doing some pretty cool stuff and I wanted to share it with people who share my interest. I'm not the most experienced machinist in the world, but I'm learning fast. There's a lot of you guys in the channel, and when I say I'm not the most experienced, like, I know what I'm doing, but I'm very aware that there are people like my grandfather who had decades of experience, and so many of you who tune in have that, and I appreciate when you guys share stuff that helps me grow as a machinist and helps me get better in here. You'd be surprised some of the stuff that we've implemented just from insightful comments. I read every single comment and I respond to every single comment. I sometimes can't respond to the responses, but we're still at a stage where I can do that, and it's really the highlight of my week is getting to chat with all of you guys. One thing I'd like to know though is, where are you located? Like, let me know where you're tuning in from. I'm really curious how far these videos are reaching. So anyway, I just want to say huge thanks. It's super humbling as we're finishing out the year to be hitting 20,000 subscribers. My goal was I thought we might get to like 200. So you never know where things can go. Sometimes you just got to have a crack. Anyway, that's it from me. I will see you guys in the comments, and I'll see you on the next one.